Hello my people, welcome to another video lesson. Today's topic will be on absolute value functions. It'll be on solving absolute value equations, which is where we'll spend most of our time. And then we'll also spend a little bit of time talking about the graphs of absolute value functions. So if this is your first video lesson with us, the way that it works is you can print the notes for this off of your It's Learning page and follow along as I go through it, or you can just do it in your notebook. I will go a lot faster through this than I do during class, but the nice thing about a video is you can pause and rewind or fast forward. You can kind of go at your own pace through this. So there'll be some times that I put a problem up and have you actually work on it. So pause the video, work on those problems, and then start it back up when you're ready to move on. Okay, so here we go. We'll jump right in. Okay, so the first question here that we're going to talk about is what is absolute value? What is absolute value? So absolute value is the distance from zero. It's the distance from zero. The best way that I've kind of found over the last few years of teaching this that I use to explain this is think about a car. So if you're driving in a car and you drive 30 miles per hour forward, okay, your speedometer in your car would show 30 miles per hour. But if you kicked it in reverse and drove backwards 35 miles per hour, the speedometer in your car still says that you're going 35 miles per hour. The direction that you're driving doesn't matter, okay? And then such is the case as absolute value. The absolute value is just the distance from zero. It doesn't matter whether you go in the positive direction or the negative direction. It's just the distance you are from zero. So for example, if we think about this in the context of a number line, if you have zero, obviously in the middle, okay, you can go 3 steps to the right, or you can go 3 steps to the left. Either way you go, you're still 3 steps away from zero. So every there are 2 points that are equidistant from zero. So that's kind of going to be a critical thing to remember. So when you see a problem like this, so our first example problem would be to solve for x, where 4 equals the absolute value of x. Those bars that you see there are called absolute value bars. Okay. So basically what this is saying is it's asking you what are the 2 numbers that are 4 steps away from zero. So you start at 0 and you go 4 to the right, or you go 4 to the left. Okay? So if you understand that concept, that there are 2 places you can either go 4 to the right or 4 to the left, this is actually going to have 2 answers. We could say that x either equals -4 or x equals +4. Those would be my 2 answers. So almost every absolute value equation that we're going to solve, you're going to look for 2 answers. Again, here we're looking for the number that's 4 to the right and also 4 to the left, because absolute value, again, is just the distance from zero. And clearly we can see there's 2 numbers that are 4 steps away from zero. You either have +4 or -4. Okay, so let's see what happens when we take it up a notch and we make things a little bit more complicated. Okay, so it says solve for x. The absolute value of 3x plus 6 equals 9. So again, if we think about this in the context of a number line, okay, I have 0 in the middle, and what I'm looking for is I'm looking for a number that is 9 steps away from zero. So I can either go to the right by 9 or I could go to the left by 9. Okay, 2 numbers that are 9 steps away from zero, either +9 or -9. Now here, the only thing that's different is what's inside the absolute value is not just x. There's some other things happening there as well. We've got 3x plus 6. So what I do here to get my 2 equations is I say, okay, 3x plus 6 can equal +9, but 3x plus 6 can also equal -9 as well. So here I have 2 equations that I can solve, and I solve each one independently. So here I subtract 6 on both sides, and I get -9 minus 6 more gives me -15. Divide both sides by 3, and I get x equals -5. Or I could get a second x value. Here I subtract 6 on both sides, and I get 3x equals 3. Divide both sides by 3, I get x equals 1. So here, my 2 solutions, my 2 possibilities that make this equation true are -5 and +1. And you can always go back and double check that. So 3 times -5 would be -15. So -15 plus 6 would be -9. and the absolute value of negative 9 is just 9, because the absolute value of negative 9, again, it's just 9 steps away from 0. We don't care about whether it's positive or negative. We're just looking for how far it is from 0. It's 9 steps away from 0. So then I take x equals 1, and I can plug that in as well. So I'd get the absolute value of 9 equals 9. So the absolute value of 9 is another way of asking you how far away from 0 is 9, and it's 9 steps, and clearly 9 equals 9. So both of those answer choices work. Okay, here's another one. You could probably pause the video here and try this. Okay, draw your number line, label the 2 places that are 6 units away from 0, and then see if you can come up with the 2 equations that you're going to use to solve this absolute value. Okay, hopefully you paused the video and worked on this problem, so I'm going to kind of show you what I would do here. Okay, so I've got my number line, and this is, again, asking me where can you go that are 6 steps away from 0, and there's 2 places. You can either go to positive 6 or you can go to negative 6. So then what I do is I take the inside of my absolute value and I set it equal to negative 6, and I also set it equal to positive 6. So if I solve these, I subtract 6 on both sides, so I get negative 2x equals negative 12. And then if I divide both sides by negative 2, let me erase that there, clean that up a little bit. If I divide both sides by negative 2, I get x equals 6. Then over here, if I subtract 6 on both sides, I get negative 2x equals 0. Divide both sides by negative 2, and you get x equals 0 as your 2 answer choices. So again, you can plug those back into the original equation and double check to see. So if I test 6 and I plug 6 in for 2x, that'd be 6 minus 12, which would give me negative 6. So the absolute value of negative 6 is 6 steps away from 0. So 6 equals 6. That works. And if I plug in a 0 for x, I get the absolute value of 6 equals 6. So again, absolute value of 6 is asking you, how many steps away from 0 are you? So 6 equals 6. That works. That's the strangest 6 I've ever drawn in my life. I have no idea what I was doing. Okay, moving on. All right, here's a super easy one. If you've paid attention to examples, the last 2 examples, this one's going to be super, super easy. So pause it now and see if you can get this one. Okay, you're back with me. We can go pretty quickly through this one because, like I said, it's pretty easy. So this equation's asking you where can you go on the number line that is 2 steps away from 0. So we can go to positive 2 or we can go to negative 2. So then I get my 2 equations. I take the inside of my absolute value and I set it equal to negative 2. And I set it equal to positive 2, and I solve each equation by adding 3. So we get x equals 1 or x equals 5. Again, you can probably check these mentally. If I plug a 1 in for x, 1 minus 3 is the square root of negative 2. So we get 2 equals 2, which checks. And if I plug a 5 in for x, I get 5 minus 3 is 2. And the absolute value of 2 is positive 2, which also equals 2. So both of those answer choices work. Okay, the next problem here is a little bit different. Example 5, solve for x. 2/5 x, absolute value of 2/5 x minus 8 plus 4 equals 12. So what's different here is the fact that we have this plus 4 right here. Okay. This plus 4 is what makes this problem a little bit different. Now, the only thing we have to do is we want to get the absolute value all by itself. So we want to isolate our absolute value. So to do that, we're going to subtract 4 on both sides. So that's the first step. So we rewrite it as the absolute value of 2/5 x minus 8 equals, subtract the 4 on both sides so you get equals 8. So now, once you get to here, this is set up to be just like one of the other problems that we do. Okay, it's set up to be just like one of the others. So now, if you think about it in the context of your number line, you're looking for 2 numbers that are 8 units away from 0. So your 2 options are negative 8 and positive 8. So then we set our equations. So 2/5 x minus 8 equals negative 8. and we have 2/5 x minus 8 equals positive 8. So two equations that will solve for x. So if I add x to both sides in the first one, I get 2/5 x equals 0. Multiply both sides by 5/2, and you get x equals 0. So on this other one, we get 2/5 x equals 16. Okay. If I multiply both sides by 5, I get 2x equals 16 times 5 is 80. Divide that by 2, and you get x equals 40. X equals 40. So there are my two answer choices there, x equals 0 and x equals 40. You can go ahead and plug those back in and double check that and make sure that that's what you get, and you'll be pleased with that answer there. Okay. All right. Next thing that could be a little bit different. Okay. The next thing that could be a little bit different is to solve for x here, where you have the absolute value of 2x plus 6 equals 4x. So you've got an x on inside the absolute value, and you have an x outside the absolute value. Okay. So much of the setup here is going to be the same. The only thing that really gets different here is you're going to have to, when you check your answers at the end, you're going to have to really be careful with checking your answers. Okay. So we're still going to set this up the same way. This is still the same kind of problem where this problem's asking you, okay, you start at 0 and you want to know where you are 4x units away from 0. And there's two ways that you can do that. You can go to the right 4x or you can go to the left 4x. Here it's going to be, it will represent the left 4x as negative 4x. Okay? So then, same concept. We take the inside of the absolute value, 2x plus 6, and we set that equal to each one of our values that are 4x units away from 0. So we have 2x plus 6 equals negative 4x, and 2x plus 6 equals positive 4x. So then we solve for x in both of these equations. So subtract 2x on both sides, and I get 6 equals negative 6x. Divide by negative 6, and I get x equals negative 1. And then over here, I get 6 equals, subtract the 2x on both sides, I get 6 equals 2x, so then I get x equals 3. Now, before we move on and circle these as our answer and move on to the next problem, you have to make sure that that you check both of these. Okay, so x equals negative 1. I'm going to plug that back in the entire equation. So if I plug that back in the entire equation, I'd get 2 times negative 1 is negative 2, plus 6 equals 4 times negative 1 is negative 4. Okay? Now, you could probably stop right here because you probably have already remembered from the very beginning that absolute value will never be a negative number. So it is impossible for this absolute value to equal negative 4 because absolute value is always just the distance from 0, and distance isn't going to be negative. Okay, it's always just how far are you away from 0. The direction doesn't matter. So even though when you add these together, you get the absolute value of 4 equals negative 4. Well, we know the absolute value of 4 is 4, and that does not equal negative 4. That is a false statement. So what we do here is we actually reject x equals negative 1 as an answer choice. We reject it. It doesn't work when we plug it back in. It's called an extraneous solution. It's called an extraneous solution. Again, and the reason it's extraneous is not because the x value that we solved for is negative. The problem is when I plug that negative x value back into the original equation, this one up here, we had some problems. We had the 4 equals negative 4, and that is not a true statement. So let's make sure we check the other x value as well. Okay, so let's go and check 3. So we'd get 3 times 2 is 6 plus 6 equals 4 times 3 is 12. Well, 6 plus 6 is the absolute value of 12. And you can already see that the absolute value of 12 equals 12. So that checks. So your only answer that works here is x equals 3. Again, x equals negative 1 was extraneous. Okay? All right, as I'm going through this, I think I can think of one thing that I did not already kind of go over with you. So I'm going to do a extra problem here. So let's call this example 7, okay? Same direction, solve for x. I'm going to show you what happens when you have a number in front of an absolute value. So let's go -2 times x plus 1 minus 1 equals -11. Okay, equals -11. Okay, so we want to go through the process of getting your absolute value isolated. So you want to get this absolute value all by itself. So you've got to do two things. You've got to move this -1 over to the other side. So let's do that first. So we'll rewrite this as -2 times the absolute value of x plus 1 equals -10. Now, the biggest mistake that I've seen students make for years on problems like this is they want to distribute the -2 into the absolute value. And that's just not how absolute value works. You don't treat absolute value like you do parentheses, to where you distribute inside the absolute value. Think about those absolute value bars as like a force field. Nothing goes in and nothing can come out. So if you think about it like a force field, nothing goes in, nothing comes out. The way that I get my absolute value by itself is I'm going to divide both sides by -2. So when I divide both sides by -2, we get the absolute value of x plus 1 equals 5. We get the absolute value of x plus 1 equals 5. And now once we get to here, we know what we're doing. We're looking for two numbers that are 5 steps away from 0. So that's +5 and -5. And then I take the inside of my absolute value and I set it equal to -5 and +5 and go through and solve for there. So then I get x equals -6 and I get x equals 4 as my two answer choices. X equals -6 and x equals 4 as my two answer choices. Okay, so the big takeaway from there is you cannot distribute the times -2 inside the absolute value. Think of the absolute value bars like a giant force field. Nothing goes in, nothing comes out. Okay, another mistake that you could have made is you could have stopped here and said, but Cozad, you said absolute value can't equal negative. Well, yes, right here it equals -10, but we haven't gotten the absolute value by itself yet. So that after we divided both sides by -2, we saw very clearly that the absolute value equaled a positive number, which is what we wanted. Okay, so that's how you handle coefficients directly in front of the absolute value. Okay, the last thing that we need to cover is a real quick review about some graphing things. Okay, so when we graph, you should be able to do this without a graphing calculator to go through and identify some of these attributes. Okay, so the first thing that you're going to do is find the coordinates of the vertex. Okay, so the parent function of the absolute value family is a v, where the vertex is at the origin. Okay, so very clearly we know from our transformations that this origin is shifting to the right and it's up. If you remember from transformations, this -4 inside the function shifts everything to the right by 4 because it's the opposite sign. So 1, 2, 3, 4, and this +4 on the outside shifts everything up 4. So we're right 1, 2, 3, 4, up 1, 2, 3, 4. So that is going to be my vertex. So the vertex here is going to be at +4, +4, because again our h value is 4, our k value is also 4. Determine if the graph opens up or down. Okay, so to determine whether it opens up or down, we look at the lead coefficient. If the lead coefficient is negative, we know that graph is going to open down because it's a reflection over the x-axis, so we know it opens down. And then it says to describe the graph as more wide or more narrow than the parent function. So if you remember from transformations, you know what this 3 does. That 3 is going to be a vertical stretch by a factor of 3. A vertical stretch by a factor of 3. And if you think about grabbing the top and the bottom of an absolute value graph and stretching it out vertically, what that's going to do is it's going to give the picture that this is more narrow than the parent function would be. It's more narrow than the parent function. Okay. Now, how are we going to actually graph this? We know where the vertex is. We know it opens down, and we know it's more narrow. Okay. Well, actually, you know that the the slope of each one of these sides is actually going to be plus and minus whatever the product of a times b is. So here our a value is 3, our b value is 1. So the slope of each side is going to be 3 and negative 3. So from this point, I go down 1, 2, 3 over 1 in each direction. Go do it again. 1, 2, 3 over 1. 1, 2, 3 over 1. And you can start to see that we're building this V. So there is your graph. Again, where the slope of this side is negative 3 and the slope of this side is positive 3. Again, the slope of those sides will always be the product of A times B. If that doesn't make sense to you, or your teacher never taught you A and B or these transformations and you don't know what these are, you can always plug in values and find these on your own. So for example, you could have plugged in what happens when x equals 3, and you could have identified that the y value from just plugging in those appropriate x values. Okay, so there you go. Here's some more graphs for you to practice. We did number 1 together already, so you don't have to go through and do that. Okay, but here's some more graphs for you to practice on your own. Sketch graphs and follow that same kind of questioning that I gave you. What are the coordinates of the vertex? Does it open up or down? And then describe the graph as more wide or more narrow than the parent function. Okay, so take a second and work on that, and then I'll give you some pointers on that in just a minute. Okay, hopefully you took some time to work on this. I'm not going to draw these graphs, but I am going to go through and tell you a few things about this. Okay, on number 2, the vertex of this graph would be at -5, -1. Hopefully you got that. That graph opens up. And this is actually the same width as the parent function because the slopes are the product of A times B, so 1 times 1 is just 1. So that's the same width as the parent function. Okay. On number 3, the vertex is at -3, +2. Okay. Oh, I'm sorry. The vertex on number 2 is -1, but you're also smart. You probably figured that out already. I wish I could say that I just did that to see if you're paying attention, but that's a lie. I made a mistake, but that's okay because I make a mistake about once every 10 years. Okay. Now number 3. Again, the vertex was -3, +2. This opens up because my lead coefficient is positive, and a slope of these sides are going to be 3/4 and -3/4, so that is more wide than the parent function. More wide than the parent function. Number 4, my vertex, there is no h value, so the vertex is at 0, -8. This is going to open down because of my negative lead coefficient. And it is more more narrow, because the slope would be +3/2 and -3/2. Okay, on number 5, we've got the vertex is at 1, -3. This opens up because the lead coefficient is positive, and the slope here is going to be 1/2 and -1/2. So this is actually going to be more wide than the parent function. And number 6, the vertex was at 6, 12. This is going to open down because of the negative lead coefficient. And the slopes would be +1/3 and -1/3, which would be more wide than the parent function. So sorry my handwriting's terrible. Hopefully you're able to discern that. And hopefully your graphs and all of your attributes matched up what I have. Okay, so that's all I have for you for this lesson. Good luck on your homework, and I'll see you next time.